Question number 32. A block of mass 100 gram is moved with speed 5 meter per second at the highest point in a closed circular tube of radius 10 centimeter. Okay. So a block is moved in a circular tube of radius 10 centimeter kept in a vertical plane. The cross section of tube is such that the block just fits into it. The block makes several oscillations inside the tube and finally stops at lowest point. Find the work done by tube. So for finding work done, first we will make the diagram. So this is the circle, okay, and we are trying to make the circular tube. So this is circular tube, and in this circular tube, a block of mass 100 gram is moved with a speed 0.5 meter per second at highest point. So we have the object here. The object is placed here, and it has speed 5 meter per second, okay, and its mass is 100 gram at highest point in a closed circular tube of radius 10 centimeter. So this radius is 10 centimeter, okay, in the kept in vertical plane. It is moving in vertical plane, so gravity is acting downward, okay, vertical plane. The cross section of tube is such that block just fits into it. The block makes several oscillations inside the tube and finally stops at lowest point. Find the work done by tube on the block during the process. Okay, so what we are going to do is we will see work done by tube. So what the tube will do the work done with the help of friction. The tube is going to work on the object with the help of friction. So as the object moves, there will be some friction acting from the surface. So we can write delta K plus delta U equal to work done by the tube or friction, whatever. Work done by tube. This we can write because there is no other force which is working, because gravity is what? Gravity is the part of conservative force delta U, and the normal force. There is one more force, normal. So normal will not be able to do any work. Why? Because displacement is perpendicular to normal. Okay, so we have two forces, three forces. One is gravity, second is normal, and third is friction. So gravity is part of conservative force, normal will not do any work, and friction is the only working. So this thing which is we have written, this is actually for work done by friction. Okay, and delta K we will write. So delta K, the final velocity, finally it comes to stop at lowest point. The object stops at lowest point. Okay, so velocity here is 0, final velocity. So we will write half m v square minus half m u square. Okay, so where v is 0, and then we'll write change in potential energy. So how much the object has descended? It has descended by 2r. So we will write minus 2 mgr. Why minus? Because the object is going down. Okay, so this is the thing, and then it is the work done by friction or work done by tube. Both are same. So we will get minus mu square minus 2 mgr. So put all the values. So minus half, m is 0.1 kg, 100 gram. So that is 0.1 kg. And then we have speed. Speed is 5. And then we have minus 2, and m is 0.1. G is 10, and r is 10 centimeter. So 10 centimeter means 0.1 again. Okay, so this much. So if we solve it, it is going to be 25, 2.5 by 2. So minus 1.25, and minus this one will be 10 into so it is, these two are cancelled, so 0.2 minus 0.2, so we will have minus 3.25 joule. So this is the work done by friction or work done by tube. So this will be our answer.